So here's the situation. Let me explain this competition. You're being asked to build a water bottle rocket, and this rocket must be launched at a target anywhere from 100 to 200 feet downfield. You will have 2 launch days, one to test, and one is the final competition. But here's the biggest question. How do you gain an advantage over the other competitors to make sure you take home the trophy? Let's set up the following scenario. There are 3 different competitors, each with varying levels of engineering knowledge. The first competitor sets out to build his rocket, trying to make it look as cool as possible. This is what he comes up with. Notice how big and heavy the rocket is. This competitor goes and tests his rocket, launching it as fast as it can go to see how far it will fly. Now here's the question. What did this competitor do wrong? First off, the first competitor didn't understand how to make the rocket aerodynamic. Making it so heavy and large is not conducive to a successful launch. Secondly, they had no testing plan. It's important to test with a plan in place so you can understand what settings to launch the rocket in to achieve different distances. So, the second competitor sets out to build his rocket, and they already know everything I just talked about. This is the second competitor's design. Notice how it is more streamlined and made of lighter materials. This competitor goes and tests following their testing plan, writing down what pressures and angles to launch the rocket at for different distances between 100 and 200 feet. So, what did this competitor do wrong? Competitor 2 could have performed more data analysis. Competitor 3 knows calculus, fluid mechanics, and has access to laboratory equipment, giving him a comparative advantage over the other competitors. By measuring the dimensions of the rocket and submitting it to a wind tunnel test, you can determine how aerodynamic the rocket is by using these equations. Competitor 3 also knows that the weight of the rocket changes as it flies, because the water escapes out the back. This video shows a close-up of the launch. In this video view from behind, notice where the water stops coming out of the rocket. By using these equations to model the flow of the water out of the rocket, and these equations to model its motion, both before and after water is in the rocket, Competitor 3 is able to create graphs showing a predicted flight path under certain conditions, as well as how far the rocket should fly at certain water levels and launch angles. By understanding and utilizing all these complex methods, you can gain an edge over your competitors and be crowned victorious. With an understanding of engineering principles, you are able to better understand and predict what happens in the environment around you. Of course, things still go wrong, so here are some bloopers for your amusement.